all collections, all iterables, lots of collection stuff that you're used to using have a way to get a stream on that collection. So in this particular case, what we want is, what I want to look at is, I don't care about the hash map, I care about the values in the hash map. So I just want just the values, which is the Twitter users, and I'm going to do some manipulation on those. I want to sort them, I want to limit them by the top X many, and I want to display that on the UI. Okay? So I'm going to get the values, I'm going to get stream.
Just to make sure that I understood.
Yeah.
We could have put stream directly on the map, but we just didn't need to.
No, you can't put it on directly on the map because map doesn't implement it. Because the map has two things. It has keys and it has values. So it doesn't really know how to stream that. So we can get all the keys and get a stream on that, or get all the values and get a stream on that.
Or entries.
Yeah, entries, yeah. So you saw me do values. I can do key set, and I can do a stream on that if I want to.
What should implement something that we can apply stream on?
What should so stream comes from, let's have a look. Stream comes from, where are we? Collection. In this particular case, collection has the stream method on it. So anything which implements collection, you can call stream on. Okay?
But map is a collection.
Map is not a collection.
No?
Map is just map. It's in the collections API, but it doesn't implement collection.
Okay.
Collection is things like lists and sets and so forth, yeah. So, yeah, I mean, it's the first thing I thought. I wanted to iterate over the map, so I should get a stream on the map. But no, you don't. You get a stream on the keys or on the values. Okay, so we're going to get a stream on our values. Values. And our stream in this particular case is a stream of Twitter users, because our values are Twitter users. Okay? So now, what can we do with stream? Now, I'm kind of a Java person through and through, so the whole concept of doing things like MapReduce was really, really new to me. But has anyone been doing things like MapReduce type operations, perhaps in other languages? Only a few of you. Good, because that's great. That means you're all starting from the same place as me. So MapReduce is kind of, yeah. Streams allow you to do MapReduce type operations, but I don't want to give that comparison, because if you don't know what MapReduce operations are, it's super not useful. Okay? So what you can do with streams is you can do things like you can filter them, you can sort them, you can change one value into a different value. It's basically like doing a SQL statement on your collection. So select these values where it looks like this, and do this to it from these things, okay? So streams are a way to query your collections. That's one way of looking at it. So in this particular case, we're going to use streams to, what are we doing? We want to reorder them. We want to order them in descending order by the number of times we've seen these Twitter users, right? We want the most seen Twitter users at the top of our leaderboard, okay? So we have a method called sorted, which takes a comparator. So comparators have been around for ages. Comparators are probably one of those places where we did used to use anonymous inner classes. And you get a compare method, and you have an O1 and O2, and you can do, in this particular case, I think we want O2.get tweets. Get tweets is the number of times they've tweeted, minus O1.get tweets. And then, of course, what we can do is replace that with a lambda. However, does anyone else find comparators really irritating to work with? Because you're like, I'm not really sure which one is O1 and which one is O2. I'm not really sure whether I'm supposed to be taking O1 from O2 or O2 from O1 in order to get ascending and descending. And then when I collapse that down into a lambda, I have two O1s and O2s going in. And I don't find them super useful. Java 8's provided some really new stuff, really nice new stuff around comparators. So I can say comparator.comparing. What I actually want to do is I want to compare on that method getTweets. Okay? So I want to use getTweets to figure out how to compare the two things. This is where method references come in really, really useful. So what I actually want to do is I want to compare on Twitter user get tweets. Okay? So that, I think, is one of the places where method handles sort of make sense. I want to sort you by comparing on this get tweets. Okay? That's all I want to do. I don't need to tell you O1 minus O2 or O2 minus O1. I just want you to use get tweets to tell you how to sort it in order. In this particular case, what we really need, though, is we need it to be reversed because we're going to sort it in descending order. But that's all we need to do. And that's where I think method references really come in handy. We didn't have to write any of that anonymous in a class or anything like that. Question?
The map, the original map isn't.
It doesn't change.
You pulled the data around from
Right.
and manipulated.
So when you do manipulations using streams, you're not changing the underlying data structure. And this is very important as well. If something else is changing the underlying data structure, it's probably going to mess up your streams. So your underlying data structure should stay static while you're streaming over it. Okay? In the same way that if you can get concurrent modification exceptions when you're dealing with lists if two things are trying to do sorting at the same time, for example. Okay? But if you're doing this, I am not, so I'm going to move on and do a few more steps of this, but this is not changing the all Twitter users map. Okay? This is just a stream of data which we can eventually collect into a new collection, which I'll show you in a minute. Okay? So the first thing is we did is we sorted it. Now we want to limit it. I'm going to limit it by this number of leaders. That happens to be the number that will fit on the screen, okay? Because 18 is a weird number otherwise. And then what I finally want to do is I want to collect this into a new list. And that's the list I'm going to display on the screen. So with streams, there are intermediate operations and terminal operations. So the intermediate operations are things like sorted, limit, filter, map. Okay, in these operations, they will return you another stream. So that lets you keep chaining up different method calls. So I'm going to filter this, I'm going to map it into this, I'm going to limit this and sort it by this. So you can keep chaining those methods up until you get to the very last method where you're going to want to either get your final value, collect all the remaining values into a new collection, or do something concrete and get something back out of it. So intermediate operations always return a stream, and collect will return you something useful, which I will show you as we collect it. So I want to collect this into a list. Collectors, to list. And then this will return me a list. This is my top tweeters. Okay? So, let's go through what this does. We do a sort operation by saying, I want you to sort on the number of tweets, and then reverse that so it's in descending order. I want you to limit the number of responses because I only want the top 18. Now, out of all of those, I want you to collect those into a list. And we'll do something with that list. Yep.
So reverse is ascend or descend, basically?
Yeah, so reversed would be descending.
If you don't put reverse, then what is the default? Ascend?
By default, it would sort it ascending.
So basically, you're taking the list and you're transforming the data. So when you have the collect list, then it's going to take all the intermediaries and make the list, and then it returns the list to the next line?
That's exactly right. So what we're doing is we're doing a bunch of operations. We're doing a bunch of operations which are going to change things, reorder things, limit things, and then right at the end you say, right, now what do you want to do with the results of that operation? In this particular case, what we want to do is collect those results into a list. We can do all sorts of different things with this, but probably in a lot of cases, what you want to do is collect them into another collection and then do something with that collection. And this is the equivalent of getting the values and then having a for loop, iterating over them and saying, okay, like sort this, do this, and then putting them into an intermediate list collection and then doing something at the end of that, looking at that list collection and going, great, okay, now we're going to do something useful with it. The useful thing we need to do with this is the list we're actually going to draw on the UI. So this is the list of Twitter users that are going to appear on our leaderboard. So I have something called an observable list. And in answer to, I think it was your question about actions in JavaFX, you can use properties and these things called observable lists. If you change the values in the observable list, the UI is looking, that's what's called observable, the UI is looking at that list and it goes, okay, you've changed. So at some point, when I get around to it, I will redraw the screen to reflect these new values in the observable list. So observable list is a type given to us by JavaFX. I use it to say, anything which goes into this is going to be on the UI, and it will get redrawn. When the list changes, the UI will redraw those values. Okay? We'll see this in action, and we can dig into it in a bit more detail if people are interested. So what I want to do is, it's got a bad name, items. This top tweeters list, this is what I want to be in my observable list. So when the UI thread sees that that's changed, then it will redraw those new values. So what I want to do is, it's quite straightforward. My items, I'm just going to do the simple brute force approach. I'm just going to set everything to be this top tweeters. Now, in answer to someone's question about single-threaded or not single-threaded, okay. Now, this onMessage method, we plumbed that in to listen to the user service. So it's on its own thread, listening to the user service, responding to changes from the user service. This thing, the items thing, is dealt with by the UI thread. So we can't do this here, because if we start changing UI thread fields and variables from underneath the UI thread from a different thread, it freaks out, and it's not a good thing to do. So what we want to do is we want to say to the UI thread, look, when you get around to it, I want you to do this. And JavaFX provides you with a method to do that. So you can say platform, run later, and then give it, what does it want? A runnable to run later. So here's where we start using lambdas again. By using this, run later, and giving it a runnable, but without all the boilerplate, you say to the UI thread, do this bit when you get around to it. You hand off that behavior to a different thread. Yes?
When you hand them off the thread, on the example you have, you don't have the platform.runLater.
What do I have?
It just has run later.
You can add a static import for run later. Okay, and then that's up here in our imports.
So you import that from, gotcha, okay.
Run later's up here. Yeah, I like static imports because they make the code smaller, but sometimes you lose where that method is coming from.
I'm sorry, and where do we connect items to the layout?
That's a very good question, because that's the next thing we're going to work on. Okay, so we haven't told the UI anything about how to draw itself. Okay, this is just the plumbing to listen to the messages from the service, and we haven't said, okay, where are you going to draw this? What is it going to look like? How do we render it? And why do I care about this items list? So what we've done is we're in our leaderboard data. So in our MVC world, this is our model bit. What we've done is we've wired it in to listen to our user service. We've told it to listen to every Twitter handle which comes in from the user service. We've said that when you see a new Twitter handle, what you want to do is update the number of times you've seen that Twitter handle, reorder this particular list so that we can now redraw the Twitter leaderboard, which we have not yet defined. So this is totally the model side of stuff.